Hello, Professor. My name is Zhao, and today I am pleased to present my research title, Machine Learning for Market Demand and Inventory Management. Uh, this project explore how we can use machine learning to forecast market demand and optimize vendor inventory, especially for mobile phones and laptops. In today's information age, electronics are everywhere and competition is fierce than ever. Business rely heavily on real-time, high-quality data to make timely strategic decisions. According to the research, over 67% of executives believe the lack of real-time data cause decision delay. One great example is Walmart, which uses big data, combine sales, weather, and social media to improve restocking. As a result, their inventory turnover increased by 10% and stock out dropped by 16%. This study aims to explore how machine learning can similarly support demand forecasting and inventory planning in the electronics sector. This project is built on three core concepts. The first is demand forecasting, is predicting future sales trends using historical data. The second is inventory control, managing stock level to balance the supply and the cost. The second is machine learning, applying data-driven algorithms for advanced predictive power. Together, they created a powerful decision support framework for business. The next is problem statement and research questions. The consumer electronics industry faces three key challenges. The first is fast-changing consumer preference, and the second is shorter product life cycle, and global competition with many partners. Because of this, managing inventory and understanding demand become difficult. So this research responds by asking five questions. The first is acute are different machine learning models. The second is what factor affect demand most. The third is which model are best for forecasting. The fourth is can machine learning help with real-time inventory tracking. The last is what is the impact on business operations. The next is methodology and data preparation. This study follows a quantitative approach using 500 records of mobile phone and laptop sale data collected from Kaggle. The key variables include brand model, RAM, storage screen size, price, and battery capacity. The data was processed, including handling missing value, removing duplicates, and fixed data types. After that, the dataset was split into training and testing set to support model evolution. The modeling process follows four main steps. The one is data collection. The second is processing. The third is feature selections. And the last is data splitting. This pipeline ensures our models are both acute and practical. The next is model selection and justification. This study used six different regression models. The first is a decision tree. Second is random forest. Uh, the third is linear regression. The fourth is SVR. The fifth is KNN, and the last is XGBoost. These models have their own advantages, and we need to test which models' production results are more consistent with the acute production situation through the data. And to compare model performance, I used MAE, RMSE, R-squirrel, these three materials to together giving a full picture of each model's performance. The next is result and discussion. Among all models tested, XGBoost performed the best. It had the highest R score and the lowest MAE and IMSE, making it the most acute. This base can help business adjust pricing strategy or return models. The next is conclusion and recommendations. This study demonstrated that machine learning, especially XGBoost and random forest, can significantly improve demand forecasting and inventory planning. Key takeaways: features like IM strong battery and camera strongly correctly the product demand. Ground proposition also play a major role in pricing and value. To improve feature, I recommended ground data source, add online review, user behavior, and search terms. Include CPI, GDP, and brand loyalty, and improve model explainability. We can use true like shape and limit. And the last one is system integration. We can embed models in ERP system for real-time decisions. Thank you.